Hello everyone. Today we're going to be covering the intro to log analysis TryHackMe room. It's completely free, and we're going to cover an intro to log analysis, best practices, and essential tools for effective detection and response. Also, my name is Joshua Spichak. I'm a cybersecurity analyst and Blue Team content creator. So let's get started. All right. Task 1, Introduction. Log analysis is an essential aspect of cybersecurity and system monitoring. At a high level, log analysis examines and interprets log event data generated by various sources, devices, applications, and systems to monitor metrics and identify security incidents. It involves collecting, parsing, and processing log files to turn data into actionable objectives. By adopting an effective log analysis strategy, security teams can more accurately respond to security incidents and gain proactive insights into potential threats. In this room, we will explore concepts related to log analysis methodology, effective logging practices, and common tools to aid detection and response. So this is the learning objectives right here. We're going to learn log analysis best practices. We're going to discover the essential tools for log analysis, and we're going to gain hands-on experience in analyzing logs by using multiple tools and technologies. And these are the room prerequisites right here. Also, it is recommended to have a general understanding of logs and how are they collected, and the preceding rooms in the log analysis module are great primers to the topics such as intro to logs. So if we open this in a new tab, both of them, we'll be able to access the intro to logs room so that way you'll better understand what logs are. But overall, logs serve as invaluable records of past events, providing essential insights to address these questions. By preserving an archive of historical activities, we can boost our security posture and protect our digital assets more effectively. So if you wanted to get a more foundational understanding of what logs are and the importance of them, highly recommend checking out the intro to logs room. And also, if you wanted to go a little bit deeper into log management and configuration, the log operations room is another really great choice as well. Awesome. All right, answer the questions below. I'm ready to proceed, and no answer needed. And it's correct. Also, I've already completed this room, but don't worry, I'm going to help you walk through my problem-solving methodology, so that way you understand how to get to the answer. So let's continue with task 2, log analysis basics. Among the various data sources collected and utilized by infrastructure systems, logs are pivotal in offering valuable insights into these systems' inner workings and interactions across the network. A log is a stream of time sequence messages that record occurring events. Log analysis is a process of making sense of the events captured in the log to paint a clear picture of what has happened across the infrastructure. So, what are logs exactly? Let me explain. Logs are recorded events or transactions within a system, device, or application. Specifically, these events can be related to application errors, system faults, audited user actions, resource uses, network connections, and more. Each log entry contains relevant details to contextualize the event, such as its timestamp, the date and time it occurred, the source, which is the system that generated the log, and additional information about the specific log event. In the above example right here, this log entry signifies an event detected by a firewall regarding unusual network activity from an internal system, indicating a potential security concern. The relevant fields to consider in this example are July 28, 1745-02, which is the timestamp this timestamp shows the event's date and time. 10.10.0.4, this refers to the system's IP address, which is the source that generated the log. Warning, this indicates the severity of the log, in this case, warning. Also, log entries are often given a severity level to categorize and communicate the relative importance or impact. These severity levels help prioritize responses, investigations, and actions based on the criticality of the events. Different systems might use slightly different severity levels, but commonly, you can expect to find the following increasingly severity levels, such as informational, warning, error, and critical. An action alert. In this case, the firewall's policy was configured to notify when such unusual activity occurs. And last but not least, the remaining fields give us specific information related to the logged event. Specifically, that unusual network activity was detected from IP 10.10.0.15 to 203.0.113.25. Based on the source zone field, the traffic appears destined for the internet external, and the application is categorized as web browsing. Alright, so why are logs important? There are several reasons why collecting logs and adopting an effective log analysis strategy is vital for an organization's ongoing operations. Some of the most common activities include system troubleshooting, cybersecurity incidents. In the security context, logs are crucial in detecting and responding to security events. So, for example, we analyze a firewall log example. Also, performing log analysis helps SOC teams and security analysis identify and quickly respond to unauthorized access attempts, malware, data breaches, and other malicious activities. And for threat hunting as well, and compliance. Now, the types of logs. As discussed in the Intro to Logs room, different components within a computing environment generate various types of logs, each serving a distinct purpose. These log types include, but not are limited to, application logs, audit logs, security logs, server logs, system logs, network logs, database logs, web server logs. That's a lot of logs. There are various types of logs, and each log type represents a unique perspective on the activities within an environment, and analyzing these logs in context. There you go. And analyzing these logs in context to one another is crucial for effective cybersecurity investigation and threat detection. Alright, we're going to answer the question below. I understand the basics of logs and am ready to proceed. No answer needed. Correct answer. Awesome. Alright, next. Moving on to task 3, investigation theory. Alright, several methodologies, best practices, and essential techniques are employed to create a coherent timeline and conduct effective log analysis investigations. Alright, timeline. When conducting log analysis, creating a timeline is a fundamental aspect of understanding the sequence of events within systems, devices, and applications. At a high level, a timeline is a chronological representation of the logged events, ordered based on their occurrence. The ability to visualize the timeline is a powerful tool for contextualizing and comprehending the events that occurred over a specific period. Within incident response scenarios, IR, timelines play a crucial role in reconstructing security incidents. With an effective timeline, security analysts can trace the sequence of events leading up to an incident, allowing them to identify the initial point of compromise and understand the attacker's tactics, techniques, and procedures. Alright, moving on to the timestamp section. In most cases, logs will typically include timestamps that record when an event occurred. With the potential of many distributed devices, applications, and systems generating individual log events across various regions, it's crucial to consider each log time's zone and format. Converting timestamps to a consistent time zone is necessary for accurate log analysis and correlation across different log sources. And you can read more about this section right here. Alright, moving on to super timelines. Yes, that's the thing. A super timeline, also known as a consolidated timeline, is a powerful concept in log analysis and digital forensics. Super timelines provide a comprehensive view of events across different systems, devices, and applications, allowing analysts to understand the sequence of events holistically. This is particularly useful for investigating security incidents involving multiple components or systems. Super timelines often include data from previously discussed log sources such as system logs, application logs, network traffic logs, firewall logs, and more. So by combining these disparate sources into a single timeline, Analysts can identify correlations and patterns that need to be apparent when analyzing logs individually. And some tools to construct super timelines are the Plazo, the Python log2 timeline. And to learn more about Plazo and its capabilities, we can visit the official documentation page here. Documentation. And also, I want to shout out a really great website and resource, CyberSec Tools. So if you wanted to learn more about a vendor, solution, or open source tool, highly recommend this website. Not sponsored or anything. It's completely free, and overall, it's continuously being updated and maintained. So if we were to look for, let's just say, search timeline, we can see Timeline Explorer, Timeliner, which is a digital forensics tool, digital machine designed for timeline analysis of file system events, Aurora, Hadabashi, Windows event logs, and Plazo right here. So like I said, if you wanted to get an understanding of different tools, vendors, etc., CyberSec Tools is a really great website to bookmark. I've done that as well. Awesome. All right, but if you wanted to get a tool to help you construct super timelines, Plazo is a really great option. We're moving on to data visualization. All right, data visualization tools such as Kibana of the Elastic Stack and Splunk help to convert wall log data into interactive and insightful visual representations through a user interface. Tools like this enable security analysts to understand the index data by visualizing patterns and anomalies, often in a graphical view, which you can see here. Multiple visualizations, metrics, and graphic elements can be constructed into a tailored dashboard view, allowing for a comprehensive single pane of glass view for log analysis operations. Very, very nice. And to create effective log visualizations, it's essential first to understand the data and sources being collected and define clear objectives for visualization. And here's an example right here to read. All right. Log monitoring and alerting section. All right. In addition to visualization, implementing effective log monitoring and alerting allows security teams to proactively identify threats and immediately respond when an alert is generated. Many theme tools, like the ones mentioned here, allow the creation of custom alerts based on metrics obtained in log events. Events worth creating alerts for may include multiple failed log attempts, privilege escalation, access to sensitive files, or other indicators of potential security breaches. Alerts ensure that security teams are promptly notified of specific activities that require immediate attention. And you can read here. And also, if you wanted to get a hands-on walkthrough on dashboards and alerting with a theme, you can check out this room right here. Right now, external research and threat intel. Identifying what may be of interest to us in log analysis is essential. It is challenging to analyze a log if we're not entirely sure what we are looking for. First, let's understand what threat intelligence is. In summary, threat intelligence are pieces of information that can be attributed to a malicious actor. Examples of threat intelligence include IP addresses, file hashes, and domains. So when analyzing a log file, we can search for the presence of threat intelligence. For example, take this Apache 2 web server entry below here. We can see that an IP address has tried to access our site's admin panel. Using a threat intelligence feed like ThreatFox, we can search our log files for known malicious actors' presence, which we can see here. Also, we have our logs, and we can also use grep to search a log file for an IP address. Nice. All right, we got questions. What's the term for a consolidated chronological view of logged events from diverse sources, often used in log analysis and digital forensics? So that's going to be consolidated chronological view. We're going to scroll up here. All right. A super timeline, also known as a consolidated timeline, is a powerful concept in log analysis and digital forensics. Super timelines provide a comprehensive view of events across different systems, devices, and applications, allowing analysts to understand the sequence of events holistically. So I believe our answer is going to be super timeline. Nice. All right. Which threat intelligence indicator would this and this be classified as? All right, so we're going to take this, and we got file hashes, domains, so let's ask AI. Could you please classify using threat intelligence what type of indicator this would be? Alright, this indicator is classified as a file hash, specifically an MD5 hash. So this is the file hash indicator category, and it is a 32 character hexadecimal string, which is the exact structure of an MD5 cryptographic fingerprint. And in threat intelligence, file hashes act as unique identifiers to track malware, malicious payloads, or altered system files. And also you can read more about the context as well. Awesome. So I believe our answer is going to be file hashes. Sweet. Moving on to task 4, detection engineering. Common log file locations. So a crucial aspect of log analysis is understanding where to locate log files generated by various applications and sources. While log file paths can vary due to system configurations, software versions, and custom settings, knowing common log file locations is essential for effective investigation and threat detection. So we have web servers, databases, web applications, operating systems, firewalls, and IDS, IPS, intrusion detection system, and intrusion prevention system, IP tables, firewall logs, and Snort. Also, I want to share with you guys another really helpful resource. And if you've seen my previous walkthroughs, you probably have seen this website, but I want to showcase it because this is a really great and helpful resource. And that resource is going to be the FIR scripts and the Windows Forensics reference tools. So what this does is that it gives us really great information about Windows security event IDs, sysmon, and much, much more. But also, we can also look at Linux and see the different types of logs, such as authentication and session logs, shell and user command history, persistence, system kernel and audit logs. And also we can expand this. So for example, syslog messages, we can see the description, path location, and forensic value, and tools and parsers, and stigma detections. So if you wanted to understand more information about logs pertaining to Windows and Linux, I would definitely recommend this website. It's completely free and open source. And also there's Linux forensics tools to help you out with your investigation as well. And all credit goes to the author of this really handy resource. And here's the GitHub to access this website as well. All credit goes to the author. Awesome. All right, now we got the logs. And while these are common log paths, it's important to note that actual paths may differ based on system configurations, software versions, and custom settings. It's recommended to consult the official documentation or configuration files to verify the correct log file paths to ensure accurate analysis and investigation. And some common patterns. In a security context, recognizing common patterns and trends in log data is crucial for identifying potential security threats. These patterns refer to the identifiable artifacts left behind in logs by threat actors or cybersecurity incidents. Fortunately, there are some common patterns that, if learned, will improve your detection abilities and allow you to respond efficiently to incidents, such as abnormal user behavior, such as multiple failed login attempts, unusual login times, geographic anomalies, frequent password changes, and unusual user agent strings. The significance of these anomalies can vary greatly depending on the specific context in the system in place, so it's essential to fine-tune any automated anomaly detection mechanisms to minimize false positives. We got some common attack signatures below. And the reason it's important is because identifying common attack signatures in log data is an effective way to detect and quickly respond to threats. Attack signatures contain specific patterns or characteristics left behind by threat actors. They can include malware infections, web-based attacks like SQL injection, cross-site scripting, or directory traversal, and more. As this is entirely dependent on the attack surface, some high-level examples include SQL injection, which can be found here. And what SQL injection is that it attempts to exploit vulnerabilities in web applications to interact with databases. So look for unusual or malformed SQL queries, structured query language, in the application or database logs to identify common SQL injection attack patterns, like we can see here. All right. Cross-site scripting, or XXS. So, exploiting cross-site scripting vulnerabilities allow attackers to inject malicious scripts into web pages. So to identify common XSS attack patterns, it is often helpful to look for log entries with unexpected or unusual input that include script tags such as this and event handlers. In the example below, a cross-site scripting attempt can be identified by the script tag here, payload inserted into the search parameter, which is a common testing method for XSS vulnerabilities. And now path traversal, last but not least. Exploiting path traversal vulnerabilities allows attackers to access files and directories outside of web applications' intended directory structure, leading to unauthorized access to sensitive files or code. So to identify common traversal attack patterns, look for traversal sequence characters, such as these, and indications of access to sensitive files. A useful directory traversal payload list to reference can be found here. And also, it's important to note, like with the above examples, that directory traversals are often URL encoded or double URL encoded to avoid detection by firewalls or monitoring tools. Because of this, these are useful URL encoded characters to know as they refer to the period and slash respectively. All right, let's answer the questions. What is the default file path to view logs regarding HTTP requests on an NGX server? So we're going to try to answer that question. And the answer is going to be access logs, error logs. Let's go with var log nginx access.log. Sweet. And a log entry containing this was identified. What kind of attack might this infer? We were already talking about URL encoding, so that's going to be path traversal. Nice. All right, task 5. Automated versus manual analysis. All right, what is automated analysis? Automated analysis involves the use of tools. For example, these often include commercial tools such as XPLG or SolarWinds Loggly. Automated analysis tools allow for processing and data analysis of logs. These tools often utilize artificial intelligence, machine learning to analyze patterns and trends. As the AI landscape evolves, we expect to see more effective automated analysis solutions. So advantages and disadvantages are here. All right, now for manual analysis. Manual analysis is the process of examining data and artifacts without using automation tools. For example, an analyst scrolling through web server log would be considered manual analysis, and manual analysis is essential for an analyst because automation tools cannot be relied upon. We got the advantages here and disadvantages. Nice. We got questions. A log file is processed by a tool which returns an output. What form of analysis is this? It's going to be tools. Let's go with automated analysis because the tool is doing the work. Nice. All right, an analyst opens a log file and searches for events. What form of analysis is this? Since it's the analyst, I believe it's going to be manual. And yes, that's correct. For example, an analyst scrolling through web server log would be considered manual analysis. Awesome. All right, task 6. Log analysis tools, command line. All right, so when analyzing collected logs, sometimes the most readily available tool we have is the command line itself. Analyzing logs through the command line provides a quick and powerful way to gain insights into system activities, troubleshoot issues, and detect security incidents, even if we don't have a SIM system configured. So many built-in Linux commands allow us to parse and filter relevant information quickly, and viewing log files using the command line is one of the most basic yet essential tasks for conducting log analysis. Several common built-in tools are used for this purpose, offering different functionalities to read and navigate through log files efficiently. And we're going to use the attack box to answer these questions. Nice. So start the attack box. Wait for it to load. It's connecting. And let it load. And then we're going to use these awesome commands. So while that is loading, I'm going to explain the commands more in depth. Alright, starting off with cat. The cat command, short for concatenate, is a simple utility that reads one or more files and displays its content in the terminal. When used for log files, it prints the entire log content to the screen. For example, to view the contents of a log file named apache.log, we can use the command listed here. And due to its large input, it's typically not the best approach for dealing with long log files. Also, there are some really beneficial resources that I want to mention, and that is ss64.com. What this is, it is a command line reference, so we can type, for example, cat, we can hit enter, and it's going to show us, and it's going to search the web for really helpful resources for the cat command, such as the command line reference. And we can see the information pertaining to cat. So if you really wanted a really helpful resource to help you better understand the commands in Linux and much, much more, highly recommend the ss64.com website, and also Explain Show will break down commands such as these to help you better understand each part as well. And both are free as well. Sweet. Alright. Awesome. This should be... Yes, we're ready to go. Alright, I'm going to view in full screen. There we go. And let's exit split view. Now let me showcase these commands. So let me do that. Click the close. Open a new terminal. Let me view, zoom in, make it easier on the eyes. I think that should be good. Yes. All right. Cat, Apache. Oh, we're not in the var directory. But I believe. Okay, I can just open it from here. So I'm doing ls. So there's your cat apache.log. So if I were to have the log, so I need to go to locate the log file under roots, root homes, intro analysis test 6. Okay, so we need to go to cd rooms, ls, cd, I believe it mentioned log analysis, root, cd rooms, intro to log analysis, so it's going to be an I, intro log analysis, okay. Actually, it's a little bit too big, so let me zoom out. Intro log analysis, ls, task, we're on currently task 6. cd 6. ls apache log. So if we do cat apache.log, we now can see all the entries in the log in our output. Awesome. All right, less. The less command is an improvement over cat when dealing with larger files. It allows you to view the file's data page by page, providing a more convenient way to read through lengthy logs. When using less to open a file, it displays the first page by default. And you can scroll down using the arrow keys or with page up and page down. For example, to view the same log file using less, we can use the command here. We're going to do that. We're going to do less. There we go. Less apache.log. And now we can use our arrow keys to go up and go down. Very nice. And to exit out, we just click on exit. Type exit or Q. There we go. Q. Nice. Yeah, you can exit the command's output via the Q key. All right, tail. The tail command is specifically designed for viewing the end of files and is very useful for seeing a summary of recently generated events in the case of log files. The most common use of tail is copied with the -F option, which allows you to follow the log file in real time, as it continuously updates the terminal with new log entries as they are generated and written. This is extremely useful when monitoring logs for live events or real-time system behavior. So by default, tail will only display the last 10 lines of the file. However, we can change this with the -N option and specify the number of lines we want to view. For example, if we only wanted to print the last 5 lines of the apache.log file and follow the logs in real time, we can use the command here. So we're going to do that. We're going to do tail -F-N5 apache.log. And now we got 5 entries instead of 10. Very, very nice. -F in real time. Sweet. All right, being able to sort, filter, and manipulate log files from the command line is a crucial aspect of performing effective log analysis. Analysts often need to extract specific information, filter relevant data, aggregate results, and transform logs to uncover insights and identify anomalies. Note, the opposite of the tail command is head, which allows you to view the first 10 lines of a file by default and takes in the same arguments. And feel free to experiment with these as well. All right, WC. The word count command. The word count command is a simple but powerful utility that can be quite useful for quick analysis and statistics gathering. The output of WC provides information about the number of lines, words, and characters in a log file. This can help security analysts understand the size and volume of log data they are dealing with before diving into a more detailed analysis. So we're going to do that. WC. Okay, Q. Exit. C. Control X. Alright, what's happened? Is it clear? A. My log is acting weird. Alright, close the terminal. Let's start fresh. Let's go to ls, cd rooms, ls, exit. Clear. You didn't see that. I'm typing too fast. ls, cd rooms, ls, cd intro log analysis, ls, cd test 6. And now ls apache.log. WC apache.log. There we go. We got our word count and more information pertaining to WC. We can use ss64.com as well. So type in WC and hit enter. And we can see the man page for the command. And what WC does is that, there we go. WC print byte, word, and line counts, count the number of bytes, white space separated words, and new lines in each given file, or standard input if none are given, or for a file of this. We can see the syntax and options as well, and descriptions. Awesome. Examples. Really handy resource. Very, very nice. All right, cut. The cut command extracts specific columns or fields from files based on specific delimiters. This is a handy command for working with log files that have structured or tab separated data. For instance, if we wanted to extract all the IP addresses in the file, we can use the cut command to specify a delimiter of a space character and only select the first field returned. That we can see here. Awesome. All right. The above command will return a list of every IP address in the log file. Expanding on this, we can change the field number to -F7 to extract the URLs and -F9 to extract the HTTP status codes. Nice. All right, sort. Sometimes it's helpful to sort the returned entries chronologically or alphabetically. The sort command arranges the data in files in ascending or descending order based on specific criteria. This can be crucial for identifying patterns, trends, or outliers in our log data. It is also common to combine the output of another command, cut for example, and use it as the input of the sort command using the pipe redirection character. For example, to sort the list of returned IP addresses from the above cut command, we can run this. And what this does is that in the above command, we pipe the output from cut into the sort command and added the -n option to sort numerically. This changed the output to list the IP addresses in ascending order. Nice. If we want to reverse the order, we can add the -r option. That's awesome. All right, unique. The unique command identifies and removes adjacent duplicate lines from sorted input. In the context of log analysis, this can be a useful tool for simplifying data lists, like collected IP addresses, especially when log entries may contain repeated or redundant information. The unique command is often combined with the sort command to sort the data before removing the duplicate entries. For example, the output of the sort command we ran above contains a few duplicate IP addresses, which is easier to spot when the data is sorted numerically. So to remove these repeatedly extracted IPs from the list, we can run this command here. Nice. And we can also append the -c option to output unique lines and prepend the count of occurrences for each line. This can be very useful for quickly determining IP addresses with unusual high traffic. And we got set and awk. All right. Both set and awk are powerful text processing tools commonly used for log analysis. They are sometimes used interchangeably, but both commands have their use cases and can allow security analysts to manipulate, extract, and transform log data efficiently. Using the substitute syntax, sed can replace specific patterns or strings into log entries. For example, to replace all occurrences of this with July 31st, 2023 in the Apache log file, we can use this. Awesome. All right, note that the / character is required to escape the / in our pattern and tells sed to treat the / as a literal character, which we can see here. Also note that the sed command does not change the Apache log file directory. Instead, it only outputs the modified version of the file to the standard output in the command line. If you want to overwrite the file, you can add the -i option to edit the file in place, or use a redirect operator such as this to save the output to the original or another file. Caution. If you use the -i option with sed, you risk overwriting the original file and losing valuable data. So ensure to keep a backup copy, please. Alright, for the awk command, a common use case is conditional actions based on specific field values. For example, to print log entries where the HTTP response code is greater than or equal to 400, which will indicate HTTP error statuses, we can use the following command here. In this case, we're using the 9 field, which in this log example refers to HTTP status codes, requiring it to be greater than or equal to 400. This only scratches the surface of the power of these commands, and it is highly encouraged to read more about the options and use cases here. So if you click on this, you will learn more about awk and sed as well. Awesome. Alright, grep. That should be our last command. Yes. And now we're going to answer some questions. I know that was a lot of commands, but don't worry, these are really beneficial commands to help you understand how to do log analysis with the command line. Alright. Last but not least, grep. The grep command is a powerful text search tool widely used on Unix systems and provides exceptional use cases in log analysis. It allows you to search for specific patterns or regular expressions within files or streams of text. Using grep can help analysts quickly identify relevant log entries that match specific criteria, particular resources or keywords or patterns associated with security incidents. The most basic usage of grep is to search for specific strings within log files. For example, if we are suspicious about any log entries that hit the admin-php webpage on the server, we can grep for admin to return any relevant results. In like unique-c command, we can append the -c option to grep to count the entries matching the search criteria. For example, because only a single line was returned in the above command here, appending -c will return 1. If we wanted to know which line number in the log file relates to the matched entries, we can add the -n option to help quickly locate specific occurrences, which we can see here. Nice. In this case, the line number 37 is pre-appended to the log entry output. So if we were to look at this awesome output, you'll see 37 somewhere here. Nice. All right. Lastly, we can invert our command using the -v option only to select lines that do not contain specific pattern or keywords. This can be useful for quickly filtering out unwanted or irrelevant lines from log files. For example, if we're not interested in any log entries that hit the index.php page, we can run the following command to filter it out. Nice. And notice that in the above command, we filtered out the index.php page and piped the output into another grep command that only pulled log entries that contain the IP address 203.64.78.90. So like with awk and sed, grep is an extremely powerful tool that cannot be fully covered in a single task. It is highly encouraged to read more about it on the official GNU manual page here, which we can see here, the official documentation for grep. Awesome. Oh yeah, lots of really helpful information. Very nice. Sweet. All right, finally, while command line log analysis offers powerful capabilities, it might only suit some scenarios. Especially when dealing with vast and complex log datasets, a dedicated log analysis solution, like the ones mentioned here, can be more efficient and offer additional log analysis and visualization features. However, the command line remains essential for quick and straightforward log analysis tasks. So with all that information, let's answer some questions. Awesome. All right, first one. Use cut on the apache.log file to return only the URLs. What is the flag that is returned in one of the unique entries? All right. Use cut to extract the 7th field, then sort the results. So we're going to use the Apache log file, but in this case, we're going to use cut to only return the URLs. We got a hint. Use cut to extract the 7th field and sort the results. So I got 7th field, and then we sort the results. So we're going to go to cut. Right here, cut dash D dash F7. Let me try that. Count the number of occurrences. Okay. So we're going to cut. Cut. I want the URLs. Dash D dash F. I believe it wants cut dash D. So let's try it. Dash F. Then sort unique. So I'm going to try this out. All right. I'm going to minimize this. Let's see if I can cut. Let me copy. It's the clipboard. Nice. Copy and paste. Copy and paste this here. We use this as our cut dash D for our delimiter. Paste. And let me fully expand this. Instead of 1, we want 7 because it's the 7th field. And then we sort. Move this. All right, and we got our flag. Nice. And we got our flag, which can be found here. So the command that I used was cut dash D, empty space dash F7 because we want the 7th field. Apache.log. Then I sorted it, and then I removed the duplicate entries using the unique command. And we found our flag, which is here. So let's see if that's our answer. Nice. All right, in the apache.log file, how many total HTTP 200 responses were logged? We got a hint. With the awk command, double equals is useful for equality comparisons. So we're going to use awk to find 200. So let me go to awk. Not grep, awk. So awk dash, I believe it is 9. Yes, 9 equal to 400 apache.log. So let me copy this. Let me minimize this screen. And then we remove this because we're now doing with awk. No, I said I want awk, not cut. I already answered cut. I want awk. All right, there we go. We paste. There we go. Cut, and we want equal. And we're trying to find the total HTTP 200 responses. So we want 200. Let's go 200. And then I believe we want WC. So that should give us our number. So let's try it out. Paste. Remove this. And boom. We got 52. Nice. Let's see if that's the answer. Sweet. Awesome. All right, in the apache.log file, which IP address generated the most traffic? Got a hint? Useful commands to help answer this question include cut, sort, and unique. So we want to find cut, sort, and unique. So what is IP address is it going to be, what field is that? IP address, I believe they mentioned the field number. Is it 1? I think it's 1. All right. I'm seeing 1. All right. They mentioned that we want to see the most entries. So we're going to do sort and unique count. So we're going to find this command. We're going to copy, put it here, and we're going, we're going to find the IP address that has the most traffic. this should work, because we're going to find the IP address field and then figure out how many occurrences there is or traffic. And I see 6 for occurrences. Oh, I see 8. So I see 6. I see 8. 145.76.33.201 looks to be the one that has the most traffic because it has the most occurrences. Something like that. Nice. 145.76.33.201. All right, finally, what is the complete timestamp of the entry where 110.122.65.76 access login.php? Got a hint? The timestamps consist of everything between the bracket and characters. So we want the complete timestamp where this access login.php. So to answer this question, I am going to grep for our IP 110.110.122.65.76 in our apache.log file. Exit. Control C. A. Alright, my command line is acting wonky. Clear. Alright, let me go back. Go back here. Let me go to ls cd rooms, ls cd intro log analysis, ls cd task 6, apache.log, and we're going to use grep. What did I do wrong with grep? Grep. Apache.log. Okay. So I need to do grep, whatever this is, apache.log. Cool. So I can just do grep 110.122.65.76 apache.log. We should get our answer. Nice. All right, cool. And now we're looking for the timestamp of the entry where this IP accessed login.php. So we see login.php, and the timestamp is going to be here, 31 July 2023, 12:34:40 plus 000. Nice. Awesome. All right, moving on to log analysis tools, regular expressions, task 7. All right, so what is regular expressions? Let me explain. Regular expressions, abbreviated as regex, are an invaluable way to define patterns for searching, matching, and manipulating text data. Regular expressions are constructed using a combination of special characters that represent matching rules and are supported in many programming languages, text editors, and software. This room won't cover the in-depth use of constructing regular expression patterns. However, the regular expressions room is a fantastic resource for learning and practicing regex. So if you wanted to learn more about regex, regular expressions, highly recommend checking out this website. And also you can use an online editor as well. So pertaining to regular expressions, I want to showcase a really helpful website, and that is regular expressions 101. Regex 101. All right, so what this website does, it allows you to test your regex here, and also you can use the community library to get an idea of different regex patterns. You can create an account. There's a regex quiz as well. And it helps you just better understand the regex patterns like quick reference, all the different tokens and patterns that you can use, and much, much more. So overall, I definitely recommend checking out Regular Expressions 101 or regex101.com to help understand regular expressions and to work on your regular expression skills and knowledge as well in the TryHackMe room. Awesome. All right. Regular expressions are widely used in log analysis to extract relevant information, filter data, identify patterns, and process logs before they are forwarded to a centralized SIM system. If you don't know what SIM is, don't worry. Let me break it down. All right, so what is a SIM, and could break down important components. All right, so what a SIM is, a SIM, or SIM, however you pronounce it, is a security information and event management system, and it is a centralized security system that collects, analyzes, and stores log data from across entire IT infrastructure to detect and respond to cyber threats in real time. And here are the key components of a SIM: data aggregation, data normalization, correlation engine, alerting dashboards, and log retention. And here are some real-world examples of a SIM in action as well. So hopefully that helps you better understand what a SIM is. Nice. All right. Now let's use grep. Regular expressions for grep. As a simple example, refer to this log file within the zip file attached to this task. You can locate the task files on the attack box under task 7. And to use them, we need to unzip them using this command and then cd regex. Nice. And this log file contains log entries from a blog site. The site is structured so that each blog post has its unique ID fetched from the database dynamically to the post URL parameter. If we are only interested in the specific blog post with an ID between 10 and 19, we can run the following grep regular expression pattern on the log file here. And notice that we added the -e option to signify that we are searching on a pattern rather than a string, which we can see here, -e is mentioned, which is what allows us to use regex. For the pattern itself, we match the literal characters post equals, after which we include the number 1, followed by the dynamic insertion of characters 0 through 9. In putting this together, what this means is that we will match any 2-digit number that starts with 1, such as 10, 11, 12, and onward. Regular expressions for log parsing. Regular expressions also play a crucial role in log parsing, which is the process of breaking down log entries into structured components and extracting relevant information from them. Log files from different sources can have diverse formats and fields, sometimes requiring additional processing to transform log data into structured, actionable information. Additionally, engineers can create custom regex patterns tailored to specific logs to map specific parts of a log entry to name fields for a SIM system. Overall, this process makes it much easier to query and analyze the extracted data later. And consider the following raw and structured log entry example. From a security standpoint, several fields here would be beneficial to extract into a SIEM for visualization. Some of these include the IP address, the timestamp, the HTTP method, post, get, or put, for example, the URL, and the user agent. And regxer is an online tool to help teach, build, and test regular expression patterns. And to follow along, copy the above log entry and paste it into the text section of the tool. I believe I already showed you guys that. Oh no, it's another one. Awesome. Another really handy resource, my patterns cheat sheet to show you the different patterns. Very, very nice. Highly recommend bookmarking these resources. I will do that. Bookmark both of them in regex 101. Nice. Alright. As a basic example, if we want to extract just the remote IP address from this log, we can think of the structure of the IP address logically. The IP address is a log entry's first part, consisting of 4 octets separated by periods. We can use the following pattern here. Then we can paste this pattern into the expression field in regxer, and you'll notice that the IP address from the log entry is successfully extracted and highlighted. Alright, breaking this pattern down, it begins and ends with a word boundary anchor. To ensure we match complete IP addresses, in between, we define the following. 0 through 9, 1 through 3, it matches 1 to 3 digits to match numbers from 0 to 999. It is important to understand while IP version for addresses octets cannot exceed 255, this simplified pattern works for our use case. And slash period, it saves and matches a utile period in the IP address. And 3, specifies that the previous capturing group here should be repeated 3 times. And again, here, this matches numbers from 0 to 999, completing the 4th octet of the IP address. We have examples of logstash and grok, which we found here. Alright, very nice. And the configuration. Alright, questions. How would you modify the original grep pattern above to match blog posts with an ID between 20 to 29? And we got a hint. The grep pattern to search for posts 10 to 20 to 19 is post 1 0 through 9. So for this, I believe it's going to be 2 0 to 9, because in our example, if I scroll up right here, what this does is that it will include the number 1 followed by the dynamic insertion of characters 0 to 9 using 0 through 9. So putting this together, 1 0 to 9 will match any 2-digit number that starts with 1, because we have it here, such as 10, 11, 12, and onward. So since we're talking about 20 to 9, I believe the answer is going to be 2 0 to 9. Awesome. Oh yes, in post as well. Very, very nice. Alright, what is the name of the filter plugin used in Logstash to parse unstructured log data? So since we're talking about unstructured log data for parsing, I believe the answer is going to be grok, because we want to. Right. Grok is a powerful Logstash plugin that enables you to parse unstructured log data into something structured and searchable. So I believe grok is going to be the answer. Awesome. Alright, moving on. Task 8, log analysis tools. CyberChef. Alright, what is CyberChef? CyberChef is a powerful tool and analysis toolkit. Created by a DCHQ, CyberChef has long been regarded as a cyber Swiss army knife. The application boosts over 300 operations, which combine to make a recipe that makes handling data a piece of cake. So some key features include encoding and decoding data, encrypting and hashing algorithms, data analysis such as parsing log files and extracting data, and many more. So this task is going to demonstrate how CyberChef can be used to parse a log file alongside the use of recipes for analysis. Before we begin, let's become familiar with the CyberChef interface. First, let's launch CyberChef in our browser by visiting CyberChef. You can see here, I'm going to bookmark this. Really helpful website, awesome. Alright, so this is the interface. And note, if you're a free user on the attack box, a local copy of CyberChef is installed and can be accessed by clicking the offline CyberChef bookmark in Firefox. So let me break down the interface. Number 1, the Operations tab. This tab right here allows you to select what we wish to do with the input. 2. The recipe, which can be found here. This tab is a collection of operations. In input 3, this tab is where we input the data or source that we want to analyze. In 4, output. This tab is the final output of the input after the operations have been applied. Awesome. So let's demonstrate CyberChef in use. In this example, I provided input this, which is TryHackMe in base 64. After selecting the 2 base 64 operation, we can see the output of TryHackMe. So I'm going to show you guys that. So input this, and then 2 base 64. And what base 64 is a notation for encoding arbitrary byte data using a restricted set of symbols that can be conveniently used by humans and processed by computers. And what this operation does is that it encodes raw data into an ASCII base 64 string. And then it encodes it to base 64. I believe. So what we did was, so we needed to, I believe it mentioned from. Okay, so from. Actually, let me show you guys a really helpful operation. So let me see if I need the quotation marks. We're going to use magic. Let me show you why magic is important. What magic does is that it attempts to detect various properties of the input data and suggests which operations could help to make more sense of it. So if we don't know what the data format is, we can use magic to help us better understand our options. Operations to use, so if I do this. Alright, we got from base 64, so if we click this recipe, we get our output, TryHackMe. Awesome. And note, if you're unsure what encoding an input is, you can use CyberChef's magic operation to take its best guess at what the input is, which we can see here, and what operations may be of use here. Awesome. Alright, regex with CyberChef. Recall from this room that regular expressions are a great way of searching and matching data. In this example, we're taking a log file that has captured SSH authentication attempts, and we are using regex to output all of the IP addresses that have attempted to authenticate. Additionally, we're using this regex pattern here to search for values that are IP addresses. Nice. So by selecting the list matches filter on the output format of the operation, we can remove all the noise from the log and output solely the IP addresses, which we can see here. Of course, this is a small example, and log files can often be hundreds of lines long. So let's keep that in mind. In uploading files in CyberChef. Files and folders can be uploaded to CyberChef. This provides us a convenient way of uploading log files to CyberChef. To do so, click on the box with an arrow pointing to it inside it. You can see here. Open file as input. And additionally, CyberChef has operators that allow you to unzip compressed files such as tar.zip or .zip. You see our log here. Nice. All right, we got questions. Locate the loganalysis.zip file under root rooms, intro loganalysis task 8. Extract the contents. Yes, we will. Let's go to our machine. Just tap. And let's extract the content. So let's go from cd . Let's go from task 6 to task 8. cd task 8. ls unzip, because the zip file log analysis. ls, we got our log analysis.zip file. So we're going to unzip. Oh no, we already done that. access.log and encoded flag.txt. Nice. Alright, upload the log file named access.log to CyberChef. And we're going to use regex to list all the IP addresses. And we're going to try to find the full IP address beginning in 212. So let's do that. this. We're going to go to CyberChef, so I need to open a browser. Give some time. Let's type CyberChef. I believe we have sample here. Or we're going to just use the website. And it should load. Nice. And we're going to input the file. We go to maybe home. Our desktop, home, rooms. There's so many rooms. Lots of learning opportunities for a nice intro log analysis. Task 8. Access.log. And now we can see the contents of our log file in the input and output fields. And then what we want to do is find the full IP address beginning 212. So what we need to do is use regular expression as our recipe. So I believe it's going to be, yes, I want to use this tab. So I want to accept these. And then take out the input. Remove the output. Alright, so let me use recipe, regular expression, and let's do regex. So to find IPs, we're going to use this pattern to search for values that are IP addresses. So we're going to copy, paste. Oh, I need to move this to the clipboard. Copy the clipboard, take this out, minimize, copy and paste to clipboard. Nice. So that way I can use it in the VM. Control C, Control V, paste. And then we got our IP addresses. Very nice. And then we need to do something more. Output format. Highlight matches. Cool. And then list matches. So we're going to list matches. Highlight matches, and we're going to list matches. Nice. And we're going to try to find 212 here. So let's go find 212. 212.14.17.145. I believe is our answer. Nice. Alright, using the same log file from question 2, access.log, a request was made that is encoded in base 64. What is the decoded value? Alright, so we got the same log file, and we're going to try to find a base 64 encoded request and decode it. Cool, so we're going to remove this regex, actually remove this regular expression, and try to find the request. Do we have a hint? We don't have a hint. Okay, so I need to find base 64. Push request in here. Get V. I see a lot of census.io. Now I need to try to find the base 64 encoded request in here. I see a VPN. Do we have any hints? Alright. Request was made as encoded in base 64. Let me do some Googling. Could you please create a regex pattern that allows me to find a request that is base 64 encoded with an access.log file? Using regex and instant response, a powerful tool. Awesome. Out. Actually, tell me the steps instead of just providing me the URLs. There we go. So the regex pattern to detect base 64 strings is going to be this. So let's try this out so that we can find our request that was encoded in base 64. So regular expression, this. Oh, that's the IPs. 1 second. Paste this. It's IPs. I want the base 64 string regular expression pattern. I'm gonna paste it here. Nice. And we're gonna use this as the pattern. So see if this thing works. It's gonna be fun. Paste. And look at that. And now we're gonna list matches. Let me list this. Output. List matches. Oh, you see post. And post. Web post. 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 ZLM. See $11. It's gonna be all of it. Decoded value. I might have missed something. Alright. Let me just take this. Post it. Let me just do some researching. Alright, task. Always good to double check your work. So let me see what I am missing. Because I believe I am on the right path. Cyber Chef. Alright, step 3. We want to find the base 64 strings in here and then decode it. So, okay, so we're going to actually use the command line this time. Let's just make it easy. Let's use the terminal. We got our base 64 string here. Nice. So we're going to ls to log analysis. ls. What am I doing? ls cd intro log analysis. And go to cd task 8. Access.log. And now we're going to try to find base 64 style strings. We're going to grep -0 -e. And then this. Let me see if my pattern works. Copy. Paste. Let me just put this in parentheses to make it easy. And then, if this works, we get our base 64 string. Access.log. Let's see if it works. Alright, base 64, where are you? Okay, so we need to use a different type of string. I believe it's only going to be 16. Alright, so give me 1 second. We're going to do grep. So instead of that pattern, we're going to use this. grep-oe thing whack a to z 0 to 9 plus and then 16 dash 0, this equals 0 dash 2. Base 64 pattern. And hopefully this works. A to Z, 0, 0 to 0, 0 to 9. A to Z, 0 to 9, plus, then we got our brackets. I believe we got our brackets. Yes, we do. And then fire. Add context of art. (16 to 0 equals 0 to 2. What am I missing? A to Z. What? Let me just use this command just in case, because we are so close. But don't worry, you'll get this answer. Paste. No, not the pattern. I meant this. All credit to whoever found this pattern. Clutch. And fire. Nice! Alright, I must have mistyped something. Grep dash OE, H to C plus 0 to 9. Oh, they did. Okay. I added a 0. Whack. Alright, we got our base 64 right here because we see the double equals. So we're going to copy this. Then go to CyberChef, which I believe, yeah. We're going to decode it and get our answer. Awesome. Alright, so let's do that. Paste. And then from page 64, THM CyberChef Wizard. Let's see if that is our answer. Nice. Alright, using CyberChef, decode the file named encodingflag.txt and use regex to extract by MAC address. What is the extracted value? So we're going to use CyberChef, but in the machine, so we're going to open file input, encodingflag.txt, and try to find the MAC address. Hopefully I pronounced it right. What is the extracted value? Oh, they want the MAC value. So 0 to, I believe it is this. I'm seeing 0 to this. 08-2E. Dash 9A. Dash 4B. Dash 7FE. Dash 610A. Dash 61, my bad. Dash 61. Nice. Oh, that's awesome. Sweet. Alright, log analysis, tools, Yara, and Sigma. So what is Sigma? Sigma is a highly flexible open source tool that describes log events in a structured format. Sigma can be used to find entries in log files using pattern matching, and Sigma is used to detect events in log files, create SIM searches, and identify threats. Also, Sigma uses the YAML syntax for its rules. This task will demonstrate Sigma being used to detect failed log events in SSH, or Secure Shell. Please note that when writing a Sigma rule, it's out of scope for this room. However, let's break down an example Sigma rule for the scenario listed above. So title, description, status, author log source, detection, false positives, and level. So in this Sigma rule, we have the keys, which can be found on the left, such as title, description, status, author, log source detection, much more, what the value is, and descriptions of them as well. And also, if you want to learn more about Sigma, there's a TryHackMe room for that. So I believe it's going to be this. Or the GitHub repo. Very, very nice. In the team. Yeah, Sigma is awesome. So you got generic detection rules, threat hunting rules, emerging threat rules, compliance rules, and placeholder rules. And also here's the official website for sigmahq.io. To learn more about Sigma, such as documentation, rules, blog, and miscellaneous. They also have a Discord. This is awesome. I'm going to bookmark this. Bookmarking. Very nice. You can see here. Sweet. So if you wanted to learn more about Sigma, highly recommend checking out the documentation in this website, sigmahq.io. Sweet. Now, this rule can now be used in SIM platforms to identify events in the process logs. If you want to learn more about Sigma, I recommend checking out the Sigma rule on TryHackMe, as well as the other resources that I mentioned, such as sigmahq.io. There's a Sigma room as well. Sweet. Yeah, learn about Sigma, introduction to Sigma rule language, syntax conversion, much, much more. So I recommend checking that out if you want to learn more about Sigma. Yay! Alright, let's learn about Yara. Yara is another pattern matching tool that holds its place in an analyst's arsenal. What Yara is a YAML formatted tool that identifies information based on binary and textual patterns, such as hexadecimal and strings. While it is usually used in malware analysis, Yara is extremely effective in log analysis. Let's look at this example Yara rule called IP Finder. This Yara rule uses regex to search for any IP version 4 addresses, and if the log file we are analyzing contains an IP address, Yara will flag it. So let's look up the keys that make up this Yara rule, such as meta, strings, and condition. Meta, strings, and condition. The examples here that are mentioned, and the descriptions. Awesome. And using Yara to detect a specific IP address. And for more information, this Yara rule can be expanded to look for multiple IP addresses based on a range, IP addresses in hex, and if an IP address lists more than a certain amount. And combined with other rules, for example, if an IP address visits a specific page or does a certain action. And if you want to learn more about Yara, you can check out the Yara room on TryHackMe. I believe it's going to be this. Awesome. Sweet. Alright, what languages does Sigma use? I believe it was YAML. Yes, Sigma uses the YAML syntax for its rules. Nice. What keyword is used to denote the title of a Sigma rule? So we're looking for keyword. Title. This title outlines the purpose of the Sigma rule. And what keyword is used to denote the name of a rule in Yara? So we're going to talk about Yara. And this key names the rule, which is rule. Awesome. Alright, task 10. In this room, we covered the basic methodology behind adopting an effective log analysis strategy. We explored the importance of log data collection, common attack patterns, and useful tools for the investigation and response processes. Next steps. To expand your SIEM and centralized logging solution capabilities, visit these modules to learn more. Alright, so let's answer the questions below. Click and continue learning. No answer needed. Correct answer. Nice. And let's close out the room. Terminate machine. Awesome. Alright. That's all for this room. Intro to log analysis, an intro to log analysis best practices, and essential tools for effective detection and response walkthrough. I hope you enjoyed this walkthrough covering the intro to log analysis TryHackMe room. I will see you guys in the next walkthrough. Have a great day. Peace.